Hello everyone, welcome to my YouTube channel. My name is Ernie. In today's video, I will show you step by step how to create daily PM2.5 time series chart for a single point using Google Earth engines and the MERRA-2 datasets. So in the previous video, I showed how to use the high resolution GHAP dataset with 1 kilometer spatial resolutions for PM2.5, which is great for spatial detail, but it's only available from 2017 to 2022. So if you need to monitor air quality for years before 2017 or other 2022, one practical alternative is MERRA-2. It's provide hourly data from 1980 to the present at roughly 50 kilometer spatial resolutions, but the temporal resolution is hourly, so it's very in temporal resolution is very high resolutions, but spatial maybe coarse than the GHAP datasets. And the trade-off, yes, it's closer spatial detail, but excellence for temporal coverage. So let's jump to the Google Earth engine first. First, you should sign in this platform. After you sign in, you can go to the code editor. In the code editor, you can write your code here. So first step is you should define your ROI. So today I will use ROI from my country Indonesia, and the data set is from FAO. This is the administrative boundary for the country boundary here, and just import it. So how to use this? You can go to the table here. We will use this term or this um, bands and give our country. If you want to use another, you just maybe you need second level. It's district level. You can use this data set second level or first level for province, and this one is for the country. So here I have already make a code for make for a country. Oh, sorry, for FAO I need for variables. So here I make my ROI as a center object with the scale is 5, and give the name is boundary of Indonesia, my own country. That's for the ROI, and then you can go to the MERA that I have already mentioned before that we will use this data set. So if you want to know about the detail about this data set, you can go to the description here and read the detail about these data sets. And as I mentioned, it's hourly, and the availability of the dataset is from 1980 until now. And today, because we will use for VM 2.5, so in this case, I will use this bed name. So I will select based on this. So just copy this snippet first and go to the code editor and make a variable called, for example, calls collections. and copy it and filter bounds, which first you should select the band. So go to here. The band's name is this. Copy it and go to here. And then filter bound with your ROI and just run it. This one is for loading your collection data sets for your uh, boundary or for your ROI. So the next step is you should define the time range. Here I will use only from 2024 July 1st until 2025 January. You can change by your case here the date, because the dataset that I have already mentioned before is available from 1980 until now. It's only for example for you, and yes, you can change it by yourself here based on the date that you need. And this one is for the time difference, because we need for make a build a daily date list here. So for time difference is the difference between the time end and the time start here, and get the rounds or how many time difference there. And this one is the functions to create daily images and to compute um, yes, the difference in day between start and uh, the date ends. And here for these functions, we define a function daily aggregations that takes a date, uh, filters the MERRA-2 collection from that date to the next day, and compute the means value of all hourly frames, and set the time series, the system with the time start, and to to the day's timestamp. And this convert many hourly images into one daily average image. So uh, these functions make a hourly to daily in average value. And after that, this one is for the collections daily that we have apply in our datasets, MERRA datasets, and yes, to a single day. And this one, the yes, if you want to visualize our maps. So this function is I will take only for first image, because there is so many image there for visualizations. And here I will define my visualizations based on my color or my palette. Just run it first. Yes, need a little time here. Okay, now it's already showing here. Just go to this setting if you want to give the palette. Okay, need a little times. So yeah, because it's need a little times for the processings. So first, if you have the data set that maybe you do the monitoring in the ground data. You can put your point. For example, here I will put one point in my map. For example, I will put point, one point here. But if you have the longitude and latitudes, your point that you have already do the monitoring in the ground data, you can put here. And here I will use these coordinates for make a chart, daily chart, and just change. So if you have another point, you just change here. Here, today I will only showing you how to change it. Sorry, Control C and copy here your longitude and the latitude, and then just run it. Oh yes, I will explain about this chart. So here we will use the chart time series based on the image that we have already collect before, and the image collection is based on the this collection daily. If you need hourly, you can adjust best by yourself, and the region is the point because here the variable is point. And yes, and the statistical, here we will use the mean value that we have already done before, and the scale is 50 kilometers or 50,000 meters, and the x property is system time start. Here is the only for the set options. We will get this title in our chart, and for horizontal is date, the title is date, and the for the vertical the title we will define is as a PM2.5, and the line it will be 2, and the point size is 2, and the series we will use blue. So this about the chart, and we will print it to show in the console uh, menu, and then just run it. Oh, before we run it, maybe we can give the palette for our map here. For example, we strike for 1%, 100%. Okay, need a little time again because yes, this very big data sets because it's provide hourly, so it's a very high temporal resolutions because it hourly, but the spatial resolution is very coarse, but the temporal resolution is very high. So it's depend on your case. Maybe you need yes, very high temporal resolution. You can use these data sets. But if you need maybe for the high spatial resolution, you can use uh, the dataset from GHAP that I have already explained in my previous video. Okay, need a little time again, maybe yes. So now it's already done for the stretching, but yes, I have already tried to apply it, but need a little time. Just fine for import these visualizations. You can copy this. So if you uh, try to run it again, it will be the visualization. It will be showing as this palette. Okay, need a little time. Just run it for the to have the chart. So here you can see it's generating the chart for that point that I have already put here. So you can put the point by the location that you have already monitored before. Maybe you have three or five or more point there you can put, and you will get the chart. Okay, need a little time here. Okay, now it's already showing here for my this point. You can see that here the chart. If you want to know or see the detail, you can click there. And here you will get this chart from July 1st, 2024 until, yes, December 31st, 2024. If you want to download this chart, you can download with the PNG here. Click here and copy. Just save it in your laptop or in your PC. And if you need the GSV value, you just download the GSV here, and you will get the GSV format. And here is already showing for us the map for all my own country, Indonesia. So yes, but this one is for the first image. It means yeah, the last image that will be showing. Okay, that's from my side today. I hope you can learn something from this tutorial. And if you need or if you have question, you can write in the comment, or if you need the code, you can write in the comment too. Thank you very much, and see you in the next video.